For our second lesson, we're going to be talking about the trigonometric ratios. So trigonometry is the branch of mathematics that deals with angles and the ratios of lengths, specifically the ratio of lengths in a right triangle. So it's very important that we're able to recognize the relationships between angles and the sides. So for example, if we look at our three angles, we have angle B, angle B, angle B, angle A, and angle C. We need to be able to recognize what side is adjacent, opposite, and of course the hypotenuse. The hypotenuse does not change. We should all be able to see that it is AC. Adjacent means next to. So which side besides from the hypotenuse is directly next to angle A? So this is angle A. So angle A touches these two sides. One of them is the hypotenuse, so the other side is AB. So that is adjacent to angle A. Now if I look and see what is opposite, so you are looking to see what is opposite, what side is it not touching? So the side that is not touching angle A is BC. Now if we look at angle B, in this case we have two adjacent sides that are not the hypotenuse, so we have both AB and BC, and opposite is the hypotenuse. This is unique because B is the right angle. And then finally we have angle C. So next to angle C is our hypotenuse and our other leg, which is BC, and across is AB. So it's important that we're able to sort of recognize this because it will make our next part very simple. So there are three trigonometric functions we're going to be talking about: sine, cosine, and tangent. And the way that we like to remember this is using SO, CA, TOA. So if we look at sine relates to SO, right? So this is the ratio of the opposite side of the angle and the hypotenuse, hence why we use the O, right? So if we look just at sines right now, so if we look at sine of A, so sine of A, so the side, so we're doing opposite over hypotenuse. So opposite is BC, hypotenuse is AC. If we do it of B, opposite is AC, hypotenuse is AC, which you should know simplifies to 1. C, opposite, we said was AB, hypotenuse is AC. This is how we set up trigonometric functions. When we go into problems, you'll see that we'll actually have numbers to fill everything in. This should be a Y. Now the other ratio that we have is cosine. So this is the ratio of the adjacent side of the angle and the hypotenuse, hence why we have the A. So now we're going to go through and look at the same thing. If we're looking at A, adjacent to it is AB over hypotenuse, which is AC. If we look at the cosine of B, there's two different ratios we can set up that are both going to be the same. So we have AB over AC, which is the same as BC over AC because they're both adjacent. And then we have C adjacent is BC, hypotenuse is AC. And then finally we have tangent. This is the ratio of the opposite angle and the opposite side and the adjacent side of an angle. So now if we look and we want to set these up, we look at A, the opposite is BC, adjacent is AB. We look at tangent of B, opposite is AC, adjacent is AB, and C, adjacent is BC, opposite is AB. So this is how we set up ratios, and it'll be important as we go into the next couple of problems. So these sine, cosine, and tangent are functions. So functions always have an input and an output. This is something you should have learned in Algebra 1. The input for all of these functions are the angles. So if we look here, when I was saying cosine of A or sine of C, those are actual angle measurements. The output is a ratio of side lengths. So if we look here, if I wanted to know, this should be angle C. Sorry about that. So if I wanted to know what is the sine of angle A, you're going to put in an angle and give me side lengths. So sine is opposite over hypotenuse. So opposite of angle A is 5 over hypotenuse 13, right? Because this is opposite, hypotenuse, adjacent for angle A. Cosine is adjacent over hypotenuse, so that would be 12 over 13. And tangent is opposite over adjacent. Very similar to angle C. For angle C, we have adjacent, hypotenuse, opposite. So for sine, we're looking at the opposite over the hypotenuse. Cosine is the opposite over the adjacent over hypotenuse. And tangent is opposite over adjacent. Now again, change B to C. And now you're going to do the same thing. So angle A. So we have opposite, adjacent, hypotenuse. Sine is opposite over hypotenuse. So that is 3 over 5. Cosine is adjacent over hypotenuse. So that is 4 over 5. And tangent is opposite over adjacent, which is 3 over 4. Now you do the same thing for C. Adjacent, opposite, hypotenuse. So now we have some Regents questions going through using some of the basic ratios. So if we want the tangent of angle ABC, the first thing I would do is mark ABC. Now I'm going to mark my sides according to this. So this is the adjacent side, this is the opposite, and this is the hypotenuse. If I want tangent, I know that should be TOA. So that is opposite over adjacent. Well, my opposite is 5, and my adjacent is 12. And that is my answer. Which equation shows the correct trigonometric ratio for angle A in the right triangle below? So angle A, so we have adjacent, opposite, hypotenuse. So if I want the sine of A, that's the opposite over the hypotenuse. So right away I can see that number 1 is incorrect. If I wanted to do the tangent of A, that is the opposite over adjacent. So I see that 2 is incorrect, as well as 4. Now I can just double check, because cosine of A should be the adjacent over the hypotenuse, which does match 3, so that is my correct answer. So now, again, PLM is this angle right here, opposite, adjacent, hypotenuse. Tangent is TOA, so opposite is 4, adjacent is 3. Now again, they're asking for which one is not correct, so I would start by setting things up. If I'm looking at angle A, we have opposite, adjacent, hypotenuse. Cosine of A would have to be adjacent, which is 12, over hypotenuse of 20. That is correct, so number 1 cannot be my answer, because I'm looking for not correct. Tangent of A is opposite over adjacent, which matches B, so it's not going to be that as my answer choice. Now they're looking at angle B, so this would be the adjacent, that's the opposite, and that's the hypotenuse. Sine of B is your opposite of 12 over your hypotenuse of 20, so it can't be 3 because that is also correct. Now I'm just going to double check. Tangent of B should be your opposite over your adjacent. So we can see that 4 is not a correct ratio. Therefore, that is the answer to this question.